Last section of chapter 2, inverse functions. So inverse functions. Inverse functions are kind of like undoing the function when we undo a function. Or you might say the opposite of the function. Now, how we show a function, if we have the function of f like this, if this is my function of f, the inverse would look like f to the negative 1x. This is showing the inverse of the function. Now, one thing, not all functions have a true inverse function. It might have an inverse relation, not an inverse function, which I will get into. But just like how we can tell if a graph, and in a graph, if it's a function by doing the vertical line test, we can see if the inverse is true if we do the horizontal line test. So like right now, this inverse is not a function because if I do this horizontal line test, it goes through more than one point. So the inverse of a parabola, the inverse of x squared is not a function. It is a relation. So first, how do we find the function? And then an identity. So if this is my function of f, if I want to find the function or the inverse, if I write this like this, we switch where the x and y are. So now if I find the inverse, I'm going to switch where the x and y. I'm going to have x is equal to 4y. And you solve for your output. So I'm going to solve for this y. So when I'm solving for that, to undo that multiplication would be division. So the inverse of this function is x divided by 4, okay, because that was equal to y. Remember, this is my output, this is my output, just two different ways. Now, if I want to see if this is true, what has to happen is if I do the composition of both of these two functions. So if I say the function of f, this is my function of f, and I'm going to put my function of f, but I'm going to put my inverse function into my function of f, okay? That's the first thing. And if I look at my inverse function, and if I put my function of f into my inverse function, these are the two things I'm checking. Now, if I look at my function of f, which is this, and I say 4 times, and I'm replacing that with my x over 4. For this one, I'm saying, here's where my x is, so 4x over, and I'm replacing that for my x. Now, if I simplify both of these, 4 times x over 4 is x, and 4x over 4 is x. So this proves the identity. Because when you put the inverse back into the function, or the function in the inverse, like we just did, then it should simplify to x. If it doesn't, then it's not the inverse. So the second question is kind of saying, which one is the inverse of the function? Now, there's two ways that you can go about doing this. You could find the inverse of the function, or else you could plug it in. So I'm going to take my function of f, and I'm going to write down the function of g. So I'm doing my composition of functions. Here's my function of g into my function of f, and I'm going to look at my function of h into my function of f. Okay, so both starting with here, but this is my function of g, and this is my function of h. Now when I plug this in, here's my function of f. I have 5 over, here's my division. And then replacing the x with this input, and replacing that x with this input. So that says x minus 2. Okay, now over here, I have 5 over. I'm replacing that x. So if you want, so that was my x here. Here's my x over here, minus 2. And I'm going to simplify both of these. And actually, I want you to try to simplify them first. I want you to try to simplify them first before you kind of check what I do. So I just simplify the bottom. So if you were like, I'm going to try to simplify it. So I just combined like terms here. So I got common denominators. That's where that 10 came from. It's a common denominator. Here you can just multiply or add those two together. So dividing by the fraction is the same thing as multiplying by its reciprocal. Multiplying by its reciprocal. So for this one, when I simplify that, I get, when I multiply by that reciprocal, 25 over x minus 8. Here, when I multiply that 5 times x over 5, I get x. So this proved the identity. So when I'm looking at this, the function of h proved the identity. So right now, this would be my inverse because it proved my identity. Okay, we're going to do this A, B, and C for all of them. Okay, first, when I'm looking at A, find the inverse function. Now, one thing that you need to note is that right away when I give you this, it's telling you the restrictions on the domain. It's telling you the restrictions on the domain. So when I find the inverse, I flip this over. So y is equal to the x squared plus 7. So I can flip-flop my x and my y plus 7. So I subtract the 7 over x minus 7. I have my y squared. Now I take the square root. Now remember, this has a plus or minus. Now we're going to get back into this, because when we take the square root of that, we have a plus or minus. So now our inverse function is equal to plus or minus square root of x minus 7. However, let's get into the domain of f. So when I just graphed this, this is this graph right here. It's saying in this domain, it's saying that the x is less than 0. So everything over here. So when I'm looking at my domain and range of f, it looks like I start at 7, because if I plug 0 into that equation, I get 7 out, and it's going up forever. So my domain has the restriction of it's including 0, because it's or equal to. So from 0, and it's going on to negative infinity. Negative infinity. Sorry, I wrote that the wrong way. Negative infinity, because it's less than. So x is less than. So it's everything over here up until that point. So my range for this is going to be, it starts at, when I plug 0 into that equation, my output is 7. So from 7, it's going on forever and ever. So it's including 7 to infinity. Now, because if I were to plug this in, if I were to plug this into our equation, I don't have a plus or minus button. What I would have to do is plug in a positive one and a negative one. So when I graph this, you'll see the positive one and the negative one graph. So this was the positive, here's the negative. Now, is this a function? No, if I did my vertical line test on this equation, this is not a function because it goes to 1 point. However, we have this domain restriction. Because of that domain restriction, that is also going to include that, yes, I'm not saying that all of this is included, okay? This isn't my whole inverse function because of this domain restriction. It only included the part on the left-hand side. Remember, it had this restriction on there. Now, once you have your domain and your range for your original, your domain for your inverse should be the same as your range as your original. Okay, that was my range. Here's my domain. My range should be the same as my domain of my original. So now I'm looking at this problem right here. This is saying my x value is from 7 into infinity. Well, both that blue and the red is true for that. Both of them are going from 7 to infinity. But my range is saying that y is negative infinity until 0. So this top equation right here, that was our plus, that's actually not included in our domain. So when I write my inverse, because it says the less than, because of this less than, my inverse is actually only the negative side of the root, only this red side. So this right here is my inverse. Just so if I were to plug this in, and if I only pick the numbers on the left-hand side of 0, it'd only be that one curve. I want you to try to do B by yourself. Find the inverse of that function, find the domain and range. And remember, once you find the domain and range of f, the opposite should be true for your range, for your inverse of domain and range. So if I were to flip my x and y, first I think I get rid of this division, multiply that over, and then I have to distribute here, because what I need to do is isolate my y's. So I moved over this 2x and I moved over this y. So I want the both y's on the same side. I need to isolate that so I can factor it out. And then I divide it. So here, right here is my inverse. Now, if I look at my domain of my original, remember, I cannot divide by 0. So that means x cannot be negative 2/3. Okay? X cannot be negative 2/3. But it can be anything on the other sides. Now, if you reach back and remember, when I look for my horizontal asymptote, or else you could try to graph this, horizontal asymptote would be, this is like a negative 1x over 3x. So since those degrees are the same, my horizontal asymptote is at negative 1/3. Now let's say if you can't remember that, If you found your inverse, like this, and then you found your domain, remember, when I'm looking at this, I cannot divide by 0. So what makes this 0 is a negative 1/3. So anything over here, I can't have my negative 1/3. So I have to make sure that that has a parenthesis to infinity. Again, if you can't remember the horizontal asymptote, if you found your inverse, your domain of your inverse is your range of your original. Your domain of your original is your range of your inverse. We're going to do the last one in class. We're going to do this last one in class. Have a great, have a grand, and have a wonderful day.